Calculus Kids, this is Dr. Callahan with Week 8 Wednesday. How are you guys doing? I hope you enjoyed having Tuesday off for the ACTs, or I guess you didn't have it off if you were actually taking the ACTs. So either way, go ahead and pause the video and answer the following 3 questions. Keep in mind that your warm-up log is due on week 9, Friday, and this is week 8, Wednesday. Okay, let's go ahead and create the assignment for you guys. Do keep in mind that in order to get your 100 points out of 100 for your practicing standard, which is going to be another grade going into the grade book on week 9 Friday, you must go ahead and check in with me on the hybrid days and upload your assignment. So if I see you every single day, because some of you guys are there every single day, you don't need to do that. You only need to do that if you're going to be absent because you're sick or if you're out doing something else for school or whatever. But there are some of you guys that I don't see every day, and it's every other day. So on the every other day assigned, make sure that you are uploading your assignment, because in order to get the 100 points out of 100 for your practicing standard at the end of week 9, you must be doing that on a regular basis. And it's really easy for me to see what you've been doing. I just go to grade on MS Team and it kind of export it into an Excel spreadsheet, and it shows me that, oh, this person uploaded their assignment on week 2 Wednesday, week 2 Thursday, week 2 Friday, but did not view the assignment on week 2 Monday or Tuesday. I mean, so it's pretty simple to see where you are at. I know it gets a little bit distracting when you're at home and you have other things that might be more interesting to do than calculus, but keep in mind that 50% of your class is, if it's online, make sure you're uploading your assignment and checking in with me. All right, so AB semester 2. Today, our topic of discussion is going to be on, it is going to be on integral of trig functions with integration by separation, which is another skill we're going to talk about. So you want to go ahead and take your white guided notes, turn it over to week 8 Tuesday. I know it's not Tuesday, but that's just what it's going to be under. Trig function with integration separation, which I can't type the entire thing there, but that's okay. Make sure you guys are checking in with me on Wednesday by, and this is your schedule here, by 9:29 a.m., which is for the end of second period. I have to take the assignment or take attendance before the end of second period. So make sure you do that and not wait till like 9 o'clock at night, because by then I'm already taking attendance. Oops, I shouldn't have done that. There we go. So due by Wednesday, by 3 p.m. is when you have to upload your assignment, but for your attendance, make sure you check in with me by second period, end of second period, 9:29 a.m. All right, so I think that is about it. Thursday, I am going to be on campus, but I am one of the committee members for the HUG Scholarship Committee. Yeah. So I will not be in the morning. I'll be on campus, but I will be reading all of your essays that you guys have been doing if you're one of the members who actually applied for the HUG scholarship. So you will have a sub on that day, and your assignment will just be on MS Team, and so it should be fairly simple on Thursday. I will also give you guys some time in class to go ahead and take the assessment that normally I assign on Wednesday. So today, I will not be giving you guys an assessment. We're going to talk about this, and then Thursday you'll have your assignment on AP College Board. So just keep that in mind, and hopefully you're watching this video so that you know that. All right, so with that said, let's go ahead and move on to today's stuff. And I just want to make sure that we're on the right screen share. I actually lectured an entire 35 minutes of probability and statistics on continuous simple interest and continuous interest equations when I realized that my screen share was still on MS Team, and I was like, oh, dang it, that really sucks. So I just want to make sure we're on the same one. So this is the breakdown. we're going to be covering today. You want to turn over to your guided notes, which looks like this. There are 3 pages, although I have to say this page is actually not in your guided notes, so I'll be printing this out individually and handing it out in class. Now, if you're on a hybrid model and you don't have a printer, you don't need to worry. You just need to copy it down. It's 10 questions. You will have this page in your guided note in addition to this page right here. All right, so with that said, let's go ahead and get started. We're going to start off with this page right here. There are 10 questions. I'm not going to go over all of them, but you at least have them available. It is on trig inverse. We're going to go over 3 different techniques, some of which we already talked about: completing the square, long division, or synthetic division. But there's one that we have not talked about, which is integration by parts, or integration by separation, I should say, not by parts, by separation. And we're going to talk about that today. All right, so with that said, here's the very first question, number 1. It's actually not that difficult, so I'm going to give you guys a second. So pause the video, give that one a try. All right, so your time's up, sorry. This is your answer right here. It's in the box, so take a look at where you are. Pause the video. Okay, second one right here. Again, this one is not super duper difficult. So pause the video, do this one on your own. All right, time's up. I'm going to go on to the answer. Take a look at your answer. Again, nothing too difficult. You know, your u equals tangent x. Du gives you a secant squared x, which is great because the secant squared x on top directly cancels. Nothing new, nothing, amazingly difficult. A is always going to be a constant, so that's 5. U is going to be the variable, so in this case, it's tangent x. All right, now let's take a look at something that looks like this one here. Okay, so with this one, you have on the bottom of all of your formulas that you are welcome to use. And as I'm looking at this right here, I noticed that, okay, what do I want my x or a to be, and what do I want my u to be? Now, which one do you think this will match closest to? I mean, so far I look at this and I'm like, okay, it could possibly match this one or this one. So let's do my u substitution. So I'm going to say let u be, well, if I just match it, it's going to be square root of x. So then du is going to be 1/2 x to the negative 1/2 dx, which is the same thing as this have 1/2 square root of x dx. So then my dx is going to be equal to 2 square root x du. And that's great because guess what? If you look over here, these two will go ahead and cancel themselves out. And so as such, you will think that you're going to be using the arc secant, but ends up being the arc sine instead. So yeah, all sorts of surprises. And a in the situation, if you're going to match it up like that, is just going to be 1. Because a squared is square root of 1. So then if you, well, actually, I'm sorry. Hold on, yeah. A is just going to be 1. Because if you rewrite this, it's 1 squared. Yeah, okay. So then, sorry, looking at this part right here, now that I have this, let's go ahead and rewrite it. Integral 1 over square root of x times the square root. You can go ahead and write this as 1 squared, which is just still 1, square root of x squared, okay, because you want to match it to this part right here. And if you go ahead and match it up like this, you will know that a has to equal 1 and u has to equal square root of x. All right, now that I match everything up, let's go ahead and change the dx. Times dx is going to be equal to 2 square root x du. Everything needs to be in terms of u. And then looking at this, square root of x cancels, and then I have a 2 on top. So I will just rewrite this as 2 integral 1 over square root of 1 squared minus square root of x squared, which is equal to 2. And you can now write out the entire part here. Arc sine u over a. U is x to the 1/2 over a, which is 1 plus c. So your answer is just 2 arc sine square root x plus c. And that is your answer. All right, let's go ahead and go to this one right over here with the definite integral. So as I look at the denominator, I notice that it is not going to be matching as easily with one of the trig inverse formulas. So if it doesn't match, you need to rewrite this from this trinomial into somewhat of a binomial. So I'm going to have to use completing the square. So let's set it up. X squared minus 2x plus blank plus 2 minus blank, because you have to go ahead and subtract it if you add something. So I have a negative 2 divided by 2 squared. So that's a negative 1 squared, which is a 1. So plus the 1 minus the 1. This piece right here, you created it yourself. So it's just the middle number divided by 2 squared plus 1. So as I look at this right here, it looks pretty clear to me that it is going to end up with the tangent because it has a plus sign, okay? So then I have my a squared plus my, or excuse me, u squared plus my a squared, because remember, u has to be the variable, a has to be the constant. And so as such, if I were to use my u sub, I will have my a equals 1, u be x minus 1, du is going to be 1 dx. And so let's go ahead and rewrite this, which will have the integral 2 to 0. Dx is going to be a du over on the very bottom, x minus 1 squared plus 1 squared, which is equal to, and you're just going to set it equal to this formula here, 1 over a, which is going to be 1 over 1, arctangent u, your u is x minus 1, divided by a, which is 1 plus c. And if you want to go ahead and rewrite that, make sure you evaluate this from 0 to 2, 2 being the upper bound, 0 being the lower bound. If I were to plug in the upper bound first and then subtract the lower bound, I will get a arc tangent. 2 minus 1 divided by 1 is just arctangent 1 minus arctangent, plug in the lower bound. 0 minus 1 is a negative 1. Okay. And then if you think about arctangent at 1, it is going to be at pi over 4 minus arctangent at negative 1 is going to be a negative pi over 4. So double negative gives you a positive. So 2 pi over 4 or pi over 2 is your area. All right, so let's go on to the next one. Okay, I'm going to jump over to this one over here. So as I look at this first, notice that you can't really match the denominator, but then this one's a little bit more complicated than the other one because you also have a 2x in numerator that I have to go ahead and cancel. As I'm thinking ahead with this, if I were to use completing the square, you're going to have x plus 3 squared, which is not going to help you cancel out And as you can see, if you go ahead and use substitution with completing the square, you'll probably have like an x plus 3 squared, but then how are you going to cancel the 2x is the problem. So you can go ahead and try that and see where it gets you. And I can tell you right now, it's not going to get you anywhere, but you should still try it just to see for yourself. Or if you think about it, if you use u sub as the denominator, derivative of x squared is 2x. So that will give you a way of canceling that part right there. So let's go ahead and set this up. So let u be x squared plus 6x plus 13. du is going to be 2x plus 6 dx. dx is du over 2x plus 6. And I know what you're thinking. You're like, okay, well, that's great. I can cancel that part here, but what about the plus 6? Well, your strategy tells you that you can also split your fraction. So your first one contains a 2x and the second one has the plus 6. I mean, that's completely something that's completely legit. You can totally do that. So then let's go ahead and give that a try. So let's rewrite this. You have 2x over u. Change your dx with the du over 2x plus 6. And what you're going to do in this situation is we're going to go ahead and just split the fraction. So that I have, let's see, how do I want to split this? Okay, so, goodness gracious, how do I want to split this? I can go ahead and rewrite it so that I have the integral of 2x plus 6 over u dx plus the integral of minus 6 over u dx. Okay, and the reason we want to do that is because if you look at the plus 6 minus 6, still gives you a 0, so that's fine. So when I replace the dx, I have the integral of 2x plus 6 over u, changing the dx with du over 2x plus 6. This is the first part of your integral. You can go ahead and cancel this piece right here, integral 1 over u du. And remember, that's going to be ln u, and your u is x squared plus 6x plus 13 plus c. So that's the answer to the first part of your integral. But then you can't forget the second part of your integral right here, which is the integral of negative 6 over u. And what you can do with this is, let's see if I can go ahead, x squared plus 6x plus 13. Let's see if I can go ahead and use a completing the square to go ahead and transform this, because there's no way you're going to cancel the negative 6 by just use substitution. So on the subtract completing the square, you're going to go ahead and do x squared plus 6x plus blank plus 13 minus blank. So your 6 divided by 2 squared is going to give you a 9. So add 9 minus 9. This piece right here is x plus 3 squared. This piece here is minus 4. So you know your u is going to be x plus 3, and your a is going to be a 2. Okay, so then which one is that going to match? Or I'm sorry, it's a plus. Just kidding, plus, not minus. Arc tangent right here. So then u is equal to x plus 3, a is equal to 2. And then, so at this point, you have a negative 6 integral du on top over x plus 3 squared plus 2 squared. So minus 6, replace this piece here, the integral, with whatever the integral of du over a squared plus u squared is going to equal to. And you should have a minus arc tangent u, and your u is x plus 3 over a, which is a 2 plus c. And that, you guys, is your answer by separation. So you're separating it by parts. Okay, let's go ahead and take a look at the next one. You can go ahead and pause the video. And here's your answer. So you can go ahead and check it yourself. But with my last one, I'm going to talk about this one right over here. So as I'm looking at this, I know that if I let my u be 4x minus x squared, my du is going to be a 2x, or I guess a 4 minus 2x. So there might be a chance I'll be able to cancel something on top. So let's give that a try, see if it gets us anywhere. If it doesn't get us anywhere, we can go back and backtrack it. So let u be 4x minus x squared. So your du is 4 minus 2x dx, and your dx is du over 4 minus 2x. Okay, well, I know that the numerator has a positive 2x, so I can rewrite this as a negative 1, 2x minus 4. That's fine too. All right, so that 2x minus 4 is pretty close to 2x minus 3. The only difference is if I have a 2x minus 3, it will be great if I can go ahead and have like a 2x minus 4 plus 1, because, that still gives me a negative 3. So let's go ahead and separate this. Integral of 2x minus 4, because that would be great if I can cancel this in the numerator and the denominator, over the square root of 4x minus x squared dx minus or plus 1 over the square root of 4x minus x squared dx. So we're going to do this separately. And my first one here is an integral of 2x minus 4 over u. Change your dx to a du over negative 1 times 2x minus 4. And guess what? This part cancels. You have a negative 1 integral 1 over u du, which is the same thing as negative 1 ln u. Your u is a 4x minus x squared plus c, but that's the first part of it. Your second piece of this right here, you would have to have the integral of something like this. You could probably use one of the formulas down here. And as I'm looking at this, as I'm looking at this right here, I don't know what I'm going to do with a 4x, because you can't make that into like an a squared or a u squared. So let's try this by completing the square. With completing the square, if I have a negative factored out, I have an x squared minus 4x. So let's complete the square with the x squared minus 4x plus blank minus blank. Your completing of the square is going to be a negative 4 divided by 2 squared, which is a negative 2 squared, which is a 4. So then this piece right here is going to be an x minus 2 squared minus 2 squared. And don't forget, this entire thing is in square roots. So which one does this actually look like? It looks like that one right there with the arc sign. So that way you know that your a is going to be x minus 2, and then your u, or excuse me, your u is going to be x, actually, yeah, minus u plus a squared. Notice how I flip-flop them because it's the same thing as negative u squared plus a squared. That's the same thing. So then u is going to be x minus 2, and a is going to be just 2. Okay, so then remember changing your du. What is your du? Your du in this case is just 1 dx, so I don't need to cancel anything. We're all good to go. So integral du over negative u squared plus a is equal to this piece right here matches with this piece right here, and you have a square root over it. Then it is going to equal to arc sine u over a. So that's going to be x minus 2 over a, which is a 2, plus c, but you're going to evaluate this from 2 to 3. I know you kind of forgot you had the upper bound, right? All right, so let's plug in the upper bound. If I plug in the upper bound, I have a negative ln, and you are going to have 4 times 3 is 12, so that's going to be a 12 minus 3 squared, 9, so that's going to be a 3, plus arc sine. 3 minus 2 is a 1, so 1/2. And you're going to be minusing the lower bound, which is at a 2. I have a feeling that I did something wrong here. Give me just a second. Let me see what I messed up on. Oh my gosh, this is such a pain in the butt. Okay, do you guys see how u equals 4x minus x squared? Du is this part that is correct. But then do you see how there is a square root right here? So it's like to the 1/2. So it's not a ln. I'm like, sorry, let's go back to this. Because I'm like, that did not look right. So this piece right here is actually a u to the 1/2 in the denominator, so u to the negative 1/2. Well, that's not too bad because I can just go ahead and do a direct reversal of the power rule. So plus a 2 over 2, which is a 1/2 over a 1/2. And if you flip this one, it's a 2. So 2 times negative 1 is a negative 2 u to the 1/2 plus c. Okay, so now let's try to plug this in with a 3. So I have a negative 2 times 3 to the 1/2. Okay, so now we're kind of on par. Plugging in the 2, you have a negative 2 times 2 to the 1/2 plus arc sine. 2 minus 2 is 0, so it's just 0. And yeah, that's it. Close your bracket. But ultimately, with the magic of your calculators, you're going to be able to find that it's going to give you a 4 minus 2 square root 3 plus pi over 6, which is going to be your answer for this. And if you want to put it into a decimal, you can just type it into your calculator. All right, you guys, that is it for the rest of the class. If you need some additional practice, I'm going to have you guys go over to this page right here. There are 3 different stations. So we're going to start off with the top one right here. Here are your answers. Then we're going to go over here to the station 2. Give it a try. Pause the video. Here are your answers for that. And then lastly, station 3. And here are your answers for this. All right, as always, stay safe and healthy and be kind to one another. I'll see you guys next time. Take care.